Welcome to aminacademy.com. In engineering mechanics, let us discuss about law of motions. First, we'll discuss about Newton's law of motion. There are three physical laws that together laid the foundation of classical mechanics. They describe the relationship between a body and the force acting upon it and its motion in response to those forces. Now, the first law. In an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity unless acted upon a force. That means, consider a box is on the table. So, no external force is acted, then the body remains the same unless otherwise the external force is acted. That means some external force is not there, the body remains at rest. Or some body is rotating, if there is no external forces acting on it, then it continues to rotate. But in naturally, the body will not continue to rotate or moving because we cannot avoid external forces like air friction, friction of the body to friction between the bodies of moving, and some other external forces. Now, the second law, in an inertial frame of reference, the vector sum of the forces F on an object is equal to the mass m of that object multiplied by the acceleration a, that is force equal F equals ma, that is mass into acceleration. Third law, when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction of the first body. Then we can explain in other way, every action there is an equal and opposite reaction of the body. Now we'll discuss more about the first law. A body at rest continues in the same state we explained unless acted upon by some external force. It appears the self-evident. That means as a train at rest on a level track will not move unless pulled by an engine. Similarly, a book lying on a table remains at rest unless it is lifted or pushed. Second one, a body moving with a uniform velocity continues its state of uniform motion in a straight line unless it is compelled by some external force to change its state. It cannot be exemplified because it is practically impossible to get rid of the forces acting on it. Now, the second law of motion, it we can state in other way also. The rate of change of momentum is directly proportional to the impressed force and takes place in the same direction in which the force acts. Let us explain further this one. Let m equal mass of body, u initial velocity of the body, v equal final velocity, then a constant acceleration, t time in seconds, required to change the velocity, change the velocity of body, change the velocity, from u to v, from u initial velocity to final velocity v. Now we'll explain further. We need some space. Now F equal force required to change. Force required to change velocity from u to v. Change the velocity from u to v. Now initial momentum of the body equal to mass into velocity mu. Final momentum of the body mv. Rate of change of momentum is change in momentum per time, mv minus mu over t. The rate of change of momentum is equal to force. Therefore, force F equal mv minus u over t. Now we know that v minus u over t is acceleration. F equal ma. Now next one, here this force unit is in Newton. If velocity is meter per second, t is in second, mass is in kg, then you can say force is in Newton. Now about third law. Every action there is an equal and opposite reaction. Here that means regarding this third law, suppose a gun is shooted, the bullet go with some certain velocity in forward motion. At the same time, the equal momentum, that is the gun is recoiled back with same force. That means same momentum. As well as if you are rowing the boat, if you are pushing the water in backward at the same force, that in forward direction the boat is moving. Like that you can explain Newton's law of motions. The further details we will do some next videos. We have done. Please subscribe our YouTube channel.